to this live podcast on Twitch where you get the news that how our researcher and scientists keep on researching on different various topics and help us to improve our lifestyle. And yes, these are the articles which we are posted on our website named postscientist.com. If you are willing to check it out, please check it out. Otherwise, listen to this podcast because it acts like an archive on the daily basis of the news and analysis and get you up to date from the research industry. So, yeah, without wasting any time, let's get started. Simple process extract valuable magnesium salt from seawater. Hmm. Since ancient times, humans have extracted salts like table salt from the ocean. While table salt is the easiest to obtain, seawater is a rich source of different minerals, and researchers are exploring which ones they can pull from the ocean. One such mineral, magnesium, is abundant in the sea and increasing usefully on the land. Magnesium has emerging sustainability related applications, including in carbon capture, low carbon cement, and potential next generation batteries. These applications are bringing renewed attention to domestic magnesium production. Currently, magnesium is obtained in the United States through an energy intensive process from salt lake brines, some of which are in danger due to droughts. The Department of Energy included magnesium on its recently released list of critical materials from domestic production. A paper published in Environment Science and Technology later shows how researchers at Pacific Northwest National Laboratory (PNNL) and the University of Washington (UW) have found a simple way to isolate a pure magnesium salt, a feedstock for magnesium metal from seawater. Their new method flows two solutions side by side in a long stream called the laminar co-flow method. The process takes advantage of the fact that the flowing solution creates a constantly reacting boundary. Fresh solution flow by never allowing the system to reach a balance. This method plays a new trick with an old process. In the mid 20th century, chemical companies successfully created magnesium feedstock from seawater by mixing it with sodium hydroxide, commonly known as ile. The resulting magnesium hydroxide salt, which gives the antacid milk of magnesia its name, was then proposed to make magnesium metal. However, the process results in a complex mixture of magnesium and calcium salt, which are hard and costly to separate. This recent work produces pure magnesium salt, enabling more efficient processing. Normally, people more separation research forward by developing more complicated materials, said PNNL chemist and UW affiliate professor of material science and engineering Chinmay Suban. This work is so exciting because we are talking a completely different approach. We found a simple process that works. When scaled, this process could help drive the renaissance of US magnesium production by generating primary feedstock. We are surrounded by a huge blue untapped resource, of course. From sequem water to solid salt, Subhan and the team tested their new method using seawater from the PNNL Sequem campus, allowing the researcher to take advantage of PNNL facilities across Washington State. As a coastal science staff member, I just called a member of his Sequem chemistry team and requested a seawater sample, said Subhan. The next day, we had a cooler delivered to our lab in Seattle. Inside, we found a cold plex and a bottle of chilled Sequem seawater. This work represents the collaboration that can help across PNNL's Richlands, Seattle, and Sequim campuses. In the laminar flow method, the researcher flow seawater alongside a solution with hydroxide. The magnesium containing seawater quickly reacts to form a layer of solid magnesium hydroxide. This thin layer acts as a barrier to solution mixing. The flow process produces a dramatically different results than simple solution mixing, said PNNL, postdoctoral research, Quing Pu, Wang. The initial solid magnesium hydroxide barrier prevents calcium from interacting with the hydroxide. We can selectively produce pure solid magnesium hydroxide without needing additional purification steps. The selectivity of this process make it particularly powerful, generating pure magnesium hydroxide without any calcium contamination allows researchers to skip energy intensive and expensive purification steps. Sustainability for the future. The new and gentle process has the potential to be highly sustainable. For example, the sodium hydroxide used to extract the magnesium salt can be generated on site using seawater and marine renewable energy. Removing magnesium is a necessary pre-treatment for seawater desalinization. Coupling the new process with existing technologies could make it easier and cheaper to turn seawater into fresh water. Hmm. The team is particularly excited about the future of the processes. This work is the first demonstration of the laminar co-flow method for selective separations. This new approach has many additional potential applications, but more work needs to be done to understand the underlying chemistry of the process. The knowledge gap offers new possibilities and research direction for powering the blue economy. We want to take this work from the empirical to the predictive, said PNNL materials scientist Elias Nacozio. There is an exciting opportunity to develop a fundamental understanding of how this process operates while applying it to important problems like creating new energy materials and achieving selective separation of hard to separate ions for water treatment and resource recovery. Of course. So these are the things, these are the simple process that our scientists uh, get from the seawater, saline water, to get these specified ions for the water treatment and many more things. So yep. Moving on towards next topic. New virus find that viruses may have eyes and ears on us. Okay, interesting. Let's see. New UMBC led research in Frontiers in Microbiology suggests that viruses are using information from the environment to decide when to sit tight inside their host and when to multiply and burst out, killing the host cell. The work has implication for antiviral drug development. Hmm. A virus' ability to sense its environment, including elements produced by its host, adds another layer of complexity to viral host interaction, says Ivan Edel, professor of biology science and senior author on the new paper. Right now, viruses are exploiting the ability to their benefit, but in the future, he says, we could exploit it to their detreatment. Not a coincidence. The new study focused on bacteriophagous viruses that infect bacteria, often referred to simply as phages. The phages in the study can only affect their host when the bacterial cells have special appendages called flagella and that help the bacteria move and mate. The bacteria produce a protein called CTRA, control A, okay, produce called CTRA that controls when they generate these appendages. The new paper shows that many appendages dependent phages have patterns in their DNA where the CTRA protein can attack sorry attach called binding sites. A phage having a binding site for a protein produced by its host is unusual, Adel says. Hmm. Even more surprisingly, uh, Adel and a paper first author Elia Mascolo, a PhD student in Adel labs, found through detailed genomic analysis that these binding sites were not unique to a single phage or even a single group of phages. Many different types of phages called CTRA binding sites, but they are All required their host to have pili or flagella to infect them. It couldn't be a coincidence, they decided. The ability to monitor CTRA levels has been invented multiple times throughout evolution by different phages that, in fact, different constantly related species demonstrate a similar trait. It's called convergent evolution, and it indicates that the trait is definitely useful. Timing is everything. Another wrinkle in the story, the first phase in which the research team identifies CTRA binding sites infects a particular group of bacteria called Caolobacterial rails. Caolobacterial are an especially well studied group of bacteria because they exist in two forms: a swarmer form that swims around freely and a stalked form that attach to a surface. The swarmer have pili, flagella, and the stalks do not. In this bacteria, CTRA also regulate the cell cycle, determining whether a cell will divide evenly into two more of the same cell type or divide asymmetrically to produce one swarmer and one stalk cell. Hmm. Because the phages can only infect swarmer cell, it is their best interest only to burst out of their host when there are many swarm cells available to infect. Generally, Caolobacterials live in a nutrient pure environments and they are very spread out, but when they find a good pocket of a micro habitat, they become stalk cells and proliferate. Adult cells eventually producing large quantities of swarmer cells. So, we hypothesis the phages are monitoring CTRA's levels, which go up and down during the life cycle of the cycle to figure out when the swarmer cell is becoming a stalk cell and becoming a factor of swarmers adult cells. And at the point they burst the cell because there are going to be many swarmers nearby to infect. Listening in, unfortunately, the method to prove this hypothesis is labor intensive and extremely difficult, so that wasn't part of their latest paper, although Errol and colleagues hope to tackle that question in the future. However, the research team sees no other plausible explanation for the proliferation of CTRA binding sites on so many different phages, all of which require pili flagella to infect their host. Even more interesting, they note, are the application for viruses that infect other organisms, even humans. Everything that we know about phages, every single evolutionary strategy they have developed, have has been shown to translate to viruses that infect plants and animals. He says it's almost a given. So if phages are listening in on their host, the virus that affects humans are bound to be doing the same. There are a few other documented examples of phages monitoring their environment in interesting ways, but none include so many different phages employing the same strategy against so many bacterial hosts. This new approach is the first broad scope demonstration that phages are listening inward on what's going on in the cell, in this case in terms of cell development adult cells, but more examples are on the way, he predicts. Already, members of his lab have started looking for receptors for other bacterial regulatory molecules in phages, he says, and they are finding them. New therapeutic avenues. The key takeaway from this research is that the virus is using cellular intel to make decisions, Adel says, and if it's happening in bacteria, it's almost certainly happening in plants and animals because if it's evolutionary strategy that makes sense, evolution will discover it and exploit it. Hmm. For example, to optimize a strategy for survival and replication on animal virus might want to know what kind of tissue it is in or how robust the host immune response is to its infection. While it might be unsettling to think about all the information viruses could gather and possibly use to make us trickier, These discovery also open up avenues for new therapies. If you are developing on antiviral drug and you know the virus is listening in on a particular signal, then maybe you can fool the virus. Errol says. Okay. There are several steps away, however, for now, we are just starting to realize how actively viruses have eyes on us, how they are monitoring what's going on around them and making decisions based on that, Errol says. It's fascinating. Of course, it's fascinating and interesting findings is given by this researcher because that's how everyone, I guess, everyone wants to do it. Otherwise, you're not going to survive it on that surface on that area. Even if I connect it to the real life, if you are ever work in the business or work in the corporate industry, you also see that you need to spoke those words only that requires to your client or that's are listening, that's he wanted to listen or she wanted to listen from your mouth. So it's necessary to read the energy and understand it and multiply it and according to that take actions like this viruses take this. So not basically they have um, eyes or ears, but it's like reading the energy and doing such action so that he can survive on the surface or in the environment. So yep, if you are connected to those things, so yep. Okay, moving on towards next topic. Approaching storm may delay launch try from NASA moon rocket. An approaching storm threatens to delay NASA next launch attempt for its moon rocket, already grounded for weeks by fuel leaks. A tropical depression in the southern Caribbean is moving towards Florida and could become a major hurricane. Managers on Friday declared that the robot is now ready to blast off on its first test flight after overcoming more hydrogen leaks during a fueling test earlier in the week. It will be the first time a crew capsule orbits the moon in 50 years. The spacecraft will carry mannequins but no astronauts. Hmm. Teams will keep monitoring the forecast and decide no later than Saturday whether to not only delay the test flight but hold the rocket off the pad and back to the hangar. It's unclear when the next launch attempt would be, whether October or even November. If the rocket must seek shelter indoors, the preference is to remain at the launch pad and drive for a Tuesday liftoff, but there are still some uncertainty in the forecast, said NASA Tom Witzmer, Deputy Associate Administrator for Exploration Systems. It takes 3 days of preparation to get the rocket back into Kennedy Space Center, Mammoth Vehicle Assembly Building, a 4 mile, 6.4 kilometer trip lasting several hours. I don't think we are cutting it close. Uh, Bitzmer told reporters, "We are just taking it a step at a time." The 332 foot 98-meter rocket can withstand gust of 85 85 meter meter per hour, 137 kilometer per hour at the pad, but only 46 meter per hour, 74 kilometer per hour once it's on the move. This would be the third launch attempt for the space launch system rocket, the most powerful ever built by NASA. Fuel leaks and other technical problems scrapped the first two trials in late August and early September. although hydrogen fueled script passed newly installed seals during Wednesday dress rehearsal. The launch team got the leakage down to acceptable levels by slowing the flow and reducing the pressure in the lines. That gave the launch team the confidence to proceed with a Tuesday launch attempt, official said. Manager said that the 30-year space shuttle program also show plenty of hydrogen fuel leaks and hurricane related rollbacks. The moon rocket main engines are actually upgraded versions of what flew on shuttles. Also, the Space Force has extended the certification of onboard batteries that are part of the flight safety system at least through the beginning of October. NASA has just two chances to launch the rocket Tuesday and October 2nd before a 2 week blackout period begins. The new launch period would open October 17. Astronauts would climb abroad for the second test flight around the moon in 2024. The third mission, targeted by 2025, would see a pair of astronauts landing on the moon. Hmm. So these are the one of the news given by the uh, NASA NASA Space Organization that it is launching the next moon space mission and also sending the mannequins to the moon, not the astronauts. And of course, it's being delayed due to weather conditions, storm weather conditions approaching in the area. So, yep. Moving on towards next topic. Mexico earthquake triggers desert tsunami 1500 miles away in Death Valley cave. Hmm. About 5 minutes after the 7.6 magnitude earthquake hit near Mexico's southwest coast Monday, typically calm water deep in Death Valley National Park cave started sloshing against the surrounding limestone rock. The reverberation from the earthquake more than 1500 miles away created what experts have called a desert tsunami, which on Monday made waves erupt up to 4 feet high in the cave, known as Devil's Hole, a pool of water about 10 feet wide, 70 feet long, and more than 500 feet deep in Amargosa Valley, Nevada. The water is the partially filled cave has become an unusual indicator of seismic activity across the world, with earthquakes across the globe as far as Japan, Indonesia, and Chile, causing the water to splash up Devil's Hole, according to the National Park Service website. Interestingly, the 6.8 magnitude earthquake that also hit Mexico's southwest coast early Thursday, not far from Monday's epicenter, did not agitate the water or create any waves in Devil's Hole, said Kevin Wilson, National Park Service uh, aquatic ecologist. Thursday earthquake struck outside Anguilla, a small town in the western state of Michoacán, just after 1 a.m. and caused at least two deaths. Two people also died in Monday earthquake. The epicenter also in Michoacán through faster east. It depends on the depth, magnitude, and location around the world, Wilson said. He said typically earthquakes along the Pacific rings of fire that reach or at or above a magnitude 7 will register in Devil's Hole. Devil's Hole is home to the under endangered pupfish, a unique breed that can face short term challenges following the geological phenomena technically called as siege. The waves in the cave stir sediment and splash away the algae growing on a shallow surf, which the pup fish rely on to feed, and can also smash some pupfish eggs, Wilson said. But he said in the long term, the movement from the earthquake helps removes the buildup of organic matter, which over time can suck oxygen from the unique ecosystem. This kind of resets the system, Wilson said. He said that the waves Monday lasted about 30 minutes before claiming down. Wilson said it's rare for the grown pupfish to die in these events, but said park rangers will continue to provide supplemental feedings for the fish, which have seen resurgence in its population in recent years. In March, officials recorded 175 of the devil's hole pupfish, up from 35 about a decade ago, and Wilson said the fall count is planned for this weekend to geothermal pool in the cave, which stays at around 93 degrees year round, coupled with its low oxygen levels, makes Devil's Hole an extreme environment. Wilson said, not to mention the infrequent but repeated earthquake aftershocks. The pupfish have survived several of these events in recent years, Wilson said. We didn't find any dead fish after the waves stopped. The last such a desert tsunami was recorded in July 2019 when waves rose up to 15 feet, according to the National Park Service officials, after a 7.1 magnitude earthquake hit near Ridge Crust in Kern County. Hmm. So these are the things. These are the one of the news which is being given to you guys. Uh, Water break. DNA nets capture COVID-19 virus in low cost rapid testing platform. Tiny net woven from DNA strands can ensure the spike protein of the virus that cause COVID-19, lighting up the virus for a fast yet a sensitive diagnostic test, and also impeding the virus from infecting cells, opening a new possible route to antiviral treatment. And according to a new study, researchers at the University of Illinois, Urbana-Champaign, and collaborators demonstrated the DNA net's ability to detect and impede COVID-19 in human cell cultures in a paper published in the Journal of the American Chemical Society. This platform combines the sensitivity of PCR and the speed and low cost of antigen tests, said study leader Xiang Wang, a professor of bioengineering and of chemistry at Illinois. We need tests like this for a couple of reasons. In is to prepare for the next pandemic. The other reason is to track ongoing viral epidemics, not only coronavirus but also other deadly and economically impactful viruses like HIV or influenza. DNA is the best known for its genetic properties, but it can also can be folded into custom nanoscale structure that can perform function and specifically bind to other structures, much like proteins do. The DNA nets the Illinois group developed were designed to bind the coronavirus spike protein, the structure that sticks out from the surface of the virus and binds to receptor on human cell to infect them. Once bound, the net gives off a fluorescent signal that can be read by an inexpensive handheld device in about 10 minutes. The researcher demonstrated that their DNA nets effectively target the spike protein and were able to detect the virus at a very low levels, equivalent to the sensitive of gold standard PCR test that can take a day or more to return results from a clinical lab. The technique holds several advantages. Wang said it does not need any special preparation or equipment that can be performed at room temperature. So all a user would do is mix to sample with the solution and read it. The researcher estimated in the study that the method would cost $1 $26 per test. Another advantage of this measure is that we can detect the entire virus which is still infectious and extinguish it from fragments that may not be infectious anymore. Wang said this not only give patient and physician a better understanding of whether they are infectious, but it could greatly improve community level modeling and tracking of active outbreaks such as through washed wastewater. In addition, the DNA nets inhibited the virus spread in live cell cultures, with the antiviral activity increasing with the size of the DNA net scaffold. This points to DNA structure potential as therapeutic agent. Wang said, "I had this idea at the very beginning of the pandemic to build a platform for testing, but also for inhibition at the same time." Wang said. Lots of other groups working on inhibitories are trying to wrap up the entire virus or the parts of the virus that provide access to antibodies. This is not good because you want the body to form antibodies with the hollow DNA net structures. Antibodies can still access the viruses. The DNA net platform can be adapted to other viruses, Wang said, and even multiplex so that a single test could detect multiple viruses. We are trying to develop a unified technology that can be used as a plug and play platform. We want to take advantage of DNA sensor, high bidding, infinity low limit of detection, low cost, and rapid preparation. Wang said the paper is tilted, mesh shaped DNA, nanostructured, designed for rapid sensitive detection and potential inhibition of the SARS CoV 2 viruses. So, yep, these are the things to capture the COVID-19 virus in a low surface and capture it in the form of virus. Yeah, yeah, testing platform, of course, to detect, of course, to detect that the patient is COVID-19 is infected or not. Yep. Moving on towards next topic. First single crystal organometallic perovskites optical fibers. Once again, it's going to be an optical fibers thing. Due to their very high efficiency in transporting electric charge from flight, perovskites are known as the next generation material for solar panels and LED displays. A team led by Dr. Lee Su at Queen's Mary University of London now have invented a brand new application of perovskites as optical fibers. The results are published in Science Advances. Optical fibers are tiny wires as thin as human hair, in which light travels at a superfast speed 100 times faster than electrons in cables. This tiny optical fiber transmit the majority of our internet data. At present, most optical fibers are made of glass. The perovskite optical fiber made by Dr. Su team consists of just one piece of a perovskite crystal. The optical fibers have a core width as low as 15 cubic meter micrometer, right, micrometer, the size of a human hair, and are very flexible. They can be bent to a radius of 3.5 millimeter compared to their polycrystal counterparts. Single crystal organometallic perovskites are more stable, more efficient, more durable, and have fewer defects. Scientists have therefore been seeking to make single crystal perovskite optical fiber that can bring this high efficiency to fiber optics. Dr. Sue Reader in photonics at Queen Mary University of London said single crystal perovskite fibers could be integrated into current fiber optical networks to substitute key component in the system, for example, in more efficient lasting and energy conversions, improving the speed and quality of our broadband networks. Dr. Su team were able to grow and precisely control the length and diameter of single crystal organometallic perovskite fibers in liquid solution, which is very cheap to run by using a new temperature growth method. They gradually change the heating position, line contact, and temperature during the processes to ensure continuous growth in the length while preventing random growth in the width. With their method, the length of the fiber can be controlled and the cross section of the perovskite fiber core can be varied. In line with their prediction, due to single crystal quality, their fibers prove to have good stability over several months, and a small transmission loss lower than zero point 0.7 decibel per centimeter, sufficient for making optical devices. They have great flexibility, can be bent to a radius as small as 3.5 millimeter and larger photocurrent values than those of a polycrystalline counterpart. The polycrystalline MAPB 3 milliwire photodetector with similar strength, length. Dr. Su said this technology could also be used in medical imaging as high resolution detectors. The small diameter of the fiber can be used to capture a much smaller pixel compared to the start of the art. So that means by using our fiber, so we can have the pixel in micrometer scales, given giving a much higher resolution image of doctors to make better and more accurate diagnosis. We could also use these fiber in textiles and that absorb the light. Then when we are wearing, for example, clothes or a device with these kinds of fiber woven into the textile, they could convert the solar energy into the electric power, so we could have solar powered clothing. So these are the things, these are the one of the things that perovskites the new future in the optical fiber, and it's very useful for the organometallic applications, sorry, organometallic devices. So yeah, I guess there is no need to explanation, of course, because author is already well explained in the article itself. An AI message decoder based on bacterial growth patterns. From a box of Cracker Jack to the Da Vinci Code, every day's enjoy a decipher secret messages, but biomedical engineers at Duke University have taken the decoder ring to place it's never been before. The patterns created by bacterial colonies, depending on the initial condition used, such as nutrient levels and space constraint, bacteria tend to grow in specific ways. The researcher created a virtual bacterial colony and then controlled growth condition and the numbers and the size of simulated bacterial dots to create an entire alphabet based on how the colonies would look after they fill a virtual petri dish. They call this encoding scheme amorphy. The encoding is not one to one, as the final simulated pattern corresponding to each letter is not exactly the same every time. However, the researcher discovered that a machine learning program could learn to distinguish between them to recognize the letter intended. A friend may see many images of me over the course of time, but none of them will be exactly the same, explained Ling Chong Yu, professor of biomedical engineering at Duke. But if the images are all consistently reinforcing what I generally look like, the friends will be able to recognize me even if they are shown a picture of me they have never seen before. To encrypt real messages, the encoder ends up creating a movie of a series of patterns, each correlating to a different letter. While they may look similar to the untrained eye, the computer algorithm can distinguish between so long as the receiver knows the set of initial conditions that leads to their creation. An interloper should not be able to crack the code without a powerful AI of their own. Yep. So these are the things. These are the one of the findings that how encoding the system encrypt the real messages through the patterns, through the things. So yeah, give the cipher a try yourself. You can type in anything from your name to Gettysburg address or even the Christmas classic. Be sure to drink your Ovaltine. We have provided you the website to download it, or is it online tool which is going to provide these things. So yep, this is the your named www.patternencoder.com. So yep, if you are willing to check it out, check it out, otherwise leave it. Moving on towards next topic, coral genome reveals cysteine surprises. Hmm. Model animals such as mice and fruit flies have provided scientists with powerful insights into how cellular biology works. However, model animals are really just a guide, and it can be risky to generalize finding across animals from studying a selection of model organisms. Cysteine is an important amino acid used in multiple biological processes, including metabolism and protein synthesis. In animals, cysteine biosynthesis was thought to be created exclusively via the transfloration pathway with the cysto cystathionine B synthase CBS enzyme as a key player. However, a previous research indicated the CBS gene had been lost in corals of the genus Acropora. The suggestion was that the scholars could not produce cysteine themselves and had to rely on symbiotic relationship with algae to receive it. We weren't searching for possible cysteine biosynthesis in Icopora, says postdoc Octavio Slasser, who worked on the Center Partnership Fund project with principal investigator Manuel Aranda from the coast and co-workers from the Australian Institute of Marine Science. We were generating a high-quality genome of the coral Acopoda loripes as a value genomic resource for future research. With the high resolution genome complete, the team decided to see if they could confirm that the CBS gene was indeed missing. Salazar could find no sign of the gene at the locus where it was meant to be, but he and his colleagues were not convinced that the oral coral had no other way of synthesizing cysteine. I started searching the genome for genes encoding for enzymes that look similar to those in other known cysteine biosynthesis pathways, such as those found in fungi and bacteria, says Salazar. I was quite surprised to find two enzymes in the coral with the similarity to a recently identified alternative cysteine biosynthesis pathway in fungi. To confirm that these enzymes encoded by the coral genes could synthesize cysteine in vivo, the researcher used yeast mutants with no cysteine biosynthesis capability and gave them the corresponding Acopoda genes. The mutants began producing cysteine. Further, the KOUST team found that both genes were present in the genomes of all animal phyla, with the exception of vertebrates, arthropods, and nematodes, the precise three groups that the most common animal models organism come from. This study proves the value of keeping on an open mind when it comes to studying living creatures, says Aranda. Sometimes knowledge can put you in a box. If you analyze data using only what you think you know, you may well miss something. Our Acupoda genome will be hugely valuable for future studies, and who knows, it could reveal other unexpected details along the way. The study appears in Science Advances. Of course. So these are the things, these are the findings. Once again, on the coral genome reveals cysteine as a new type of gene present in the seafood and in the seawater mammals. So yep. Moving on towards next topic. New research throws doubt on old ideas of how hearing works. Hmm. The way in which we experience music and speech differs from what has until now been believed. This is the conclusion of the study by researcher at Linkoping University, Sweden, and Oregon Health and Science University, US. The result have been published in Science Advances and may make it possible to design other cochlear implants. We are social creatures. The sound of other people's voice is important for us, and our hearing is directed at experiencing and distinguishing voices. And human speech sound that arrives at the outer ear is carried by the ear drum to the spiral-shaped inner ear, also known as the cochlear. The sensor cells of hearing, outer and inner ear cells, are located in the cochlea. The sound waves cause the hairs of the inner hair cell to bend, sending a signal through the nerves to the brain, which interprets the sound we hear. For the past 100 years, we have believed that each sensory cell has its own optimal frequency, a measure of the number of sounds waves per second. The hair cell responds more strongly to this frequency. This idea means that a sensory cell with an optimal frequency of 1000 hertz would respond much less strongly to sound with a frequency slightly lower or higher. It has also been assumed that all parts of the cochlea work in the same way now. However, a research team has discovered that this is not the case of sensory cells that process sound with the frequency under 1000 Hz, considered to be low frequency sound. The vowel sound in human speech lie in this area. Our study shows that many cells in the inner ear react simultaneously to low frequency sound. We believe that this make it easier to experience low frequency sound than would otherwise be the case, since the brain receives information from many sensory cells at the same time, says Anders Finchberg, professor in the Department of Biomedical and Clinical Science at Linköping University. The scientists believe that the construction of our hearing system makes it more robust. If more sensory cells are damaged, many other remains that can send nerve impulses to the brain. It is not only the vowel sound of human speech that lie in the low frequency region. Many of the sounds that go to make up music also lie here. Middle C on a piano, for example, has a frequency of 262 Hz. This result may eventually be significant for people with severe hearing impairments. The most successful treatment currently available in such cases is a cochlear implant in which electrodes are placed into the cochlea. The design of current cochlear implants is based on the assumption that each electrode should only give nerve stimulation at certain frequency in a way that tries to copy what we believed about the function of our hearing system. We suggest that changing the simulation method at low frequency will be more similar to the natural simulation, and the hearing experience of the user should in this way be improved, says Anders Frinsberg. The researchers now plan to examine how their new knowledge can be applied in practice. One of the projects they are investigating concerns new method to stimulate the low frequency parts of the cochlea. This result come from experiments on the cochlea of Geneva pigs, whose hearing in the low frequency region is similar to that of humans. Okay, I guess once again there is no need for explanation or having short summary of this article because it's well explained by the author itself. So we are moving towards the next topic: catalytic process with lignin could enable 100% sustainable aviation fuel. Okay, so many of the researchers are focusing on the aviation fuel industry. So yeah, of course, it's the requirement. And under utilized natural resource could be just what the airline industry need to curb carbon emission. Yes, research at three institute, the U.S. Department of Energy, National Renewable Energy Laboratory, NREL, and the Massachusetts Institute of Technology (MIT) and the Washington State University report success in using lignin as a part towards a drop in 100% sustainable aviation fuel. Lignin makes up the rigid parts of the cell walls of plants. Other parts of the plants are used for biofuels, but lignin has been largely overlooked because of the difficulty in breaking it down chemically and converting it into useful products. The newly published research demonstrated a process the researcher developed to remove the oxygen from lignin, such that the resulting hydrocarbons could be used as a jet fuel blend stock. The research continues deoxygenation to lignin to jet range aromatic hydrocarbons appeared in the journal Joule. Greg Beckman and Earl Christians are the researchers involved from NREL. The paper points to the need to use sustainable sources for jet fuel as the airline industry has pledged dramatically reduce carbon emission. Airline consumed 106 billion gallons of jet fuel globally during 2019, and that number is expected to more than double by 2050. Accomplishing the industry goals of achieving net carbon neutrality during the same period will require a massive deployment of sustainable aviation fuel (SAF) with high blend limits with conventional fuel. Yes, jet fuel is blended mixture of different hydrocarbon molecules including aromatics and cycloalkenes. Current commercialized technology do not produce these components to qualify for 100% SAF. Instead, SAF blend stocks are combined with conventional hydrocarbon fuels as the largest source of renewable aromatics in nature. Lignin could hold the answer to achieve a complete bio-based jet fuel. This newly published work illustrates the ability of a lignin pathway to complement existing and other developing pathways. Specifically, the lignin pathway described in the new work allows the SAF to have fuel system compatibility at higher blend ratios. Because of the recalcitrance, lignin is typically burned off for heat and power or used only in low value application. Previous research has yielded lignin oils with the high oxygen contents ranging from 27% to 34%, but to be used as a jet fuel, that amount must be reduced to less than a half percent. Other processes have been tried to reduce the oxygen content, but the catalyst involved required expensive noble metals and proved to be low yielding. Researchers at the trio of the institution demonstrated an efficient method that used earth abundant molybdenum carbide as the catalyst in a continuous process, achieving an oxygen content of about 1%. Hmm. I guess there is no need for explanation because, of course, the jet fuel needs for a total uh, sustainable aviation fuel in the aviation industry, and that's all world countries need to be required in the future world. Okay, we have an interesting topic. Okay, let's read it and see what we get. Wearable sensors styled into t-shirts and face masks. Right, let's see, read it. Imperial researchers have invented new low-cost sensors that monitor breathing, heart rate, and ammonia into t-shirts and face masks. Potential applications range from monitoring exercise, sleep, and stress to diagnosing and monitoring disease through breath and vital signs. Spun from a new Imperial developed cotton based conductive thread called P-Cortex, the sensor costs little to manufacture, just 0.15 cents, produces a meter of thread to seamlessly integrate more than 10 sensors into clothing, and P-Cortex is compatible with industry standard computerized embroidery machines. First author of the research, Fahad Alans-Bona, a PhD candidate, Imperial Department of Bioengineering, said the flexible medium of clothing means our sensors have a wide range of application. Yes, they are also relatively easy to produce, which means we could scale up manufacturing ushers in a new generation of wearables in clothing. The researcher embroidered the sensor into the face mask to monitor breathing, a t-shirt to monitor heart activity, and the textile to monitor gases like ammonia, a component of the breath that can be used to detect liver and kidney functions. The ammonia sensor were developed to test whether a gas sensor could also be manufactured using embroidery. Fahad added, we demonstrated application in monitoring cardiac activity and breathing and sensing gases. Future potential applications include diagnosing, monitoring disease, and treatment monitoring the body during exercise, sleep, and stress, and using bacteria heaters and anti-static clothing. The research is published in Materials Today. Seamless sensors. Wearable sensors like those on smartwatches let us continuously monitor our health and well-being non-invasively. Until now, however, there has been a lack of sustainable conductive threads, which explains why variable sensors seamlessly integrate into clothing aren't yet widely available. Enter P-Cortex, developed and spun into sensor by Imperial researcher. The material is machine washable and is less breakable and more electrically conductive than commercially available silver-based conductive threads, meaning more layers can be added to create complex types of sensor. The researcher tested the sensor against commercially available silver-based conductive threads during and after they were embroidered into clothing. During embroidery, P cortex was more reliable and less likely to break, allowing for more layers to be embroidered on the top of each other. After embroidery, P-Cortex demonstrated lower electrical resistance than the silver-based threads, meaning they perform better at conductivity electricity. Lead author Dr. Fidat Gooders, also the Department of Engineering, said P-Cortex is high performing, strong, and adaptable to different needs. It's readable, scalable, meaning we can produce large volume inexpensively using both domestic and industrial computerized embroidery machines. Our research opens up existing possibilities for variable sensor in everyday clothing by monitoring breathing, heart rate, and gases. They can already be seamlessly integrated and might even be able to help diagnose and monitor treatments of disease in the future. The embroidered sensor retained the intrinsic properties of the fabric, such as wearability, breathability, and feel on the skin. They are also machine washable to up to 13 degrees Celsius. Next, the researcher will explore new application areas like energy storage, energy harvesting, and biochemical sensing for personalized medicine, as well as finding partners for commercialization. PSS, modified cotton conductive thread for manufacturing of textile based electrical variable sensor by computerized embroidery, was published September 6, 2022 in Materials Today. Okay. So these are okay. One of the application being used by the scientist, by the researcher, and I guess once again there is no need for explanation. And we are moving on towards next topic and the last topic of the day. Wave energy technology could generate electricity from ocean waves, clothing, cars, and buildings. Hmm. Imagine this: clothing that charges your smartwatch as you walk, buildings that vibrate in the wind and power your lights, a road that extracts energy from the friction created by moving cars, and flexible structure that change shape in ocean waves to generate clean electricity for communities around the world. It is not science fiction. Someday we could harness these natural occurring energy resources thanks to a fledgling technology domain that just earned its first patent, distributed embedded energy converter technologies, or DEC tech, pronounced DEC tech for short. The invention first patent is specifically for application in marine renewable energy. Okay, clean power generated from ocean and rivers, waves, currents, and tides. But DEC tech could eventually transform sources of everyday energy, including almost all physical motions or dynamic shapes, changes into electricity or other forms of usable energy. The tech domain has legs and is growing. Okay, said Blake Borden, a senior engineer at the National Renewable Energy Laboratory (NREL) and the lead inventor of the on the patent, along with Joachim Weber, chief engineer for NEREL's water power program. Tech might very well have the legs to move into buildings, clothing, and roads, but it is starting in the ocean. Okay. The patent shows that we are gaining momentum in a fruitful area of research. Hmm. Okay. Borden said. So how this promising tech domain actually work? Hmm. Picture once again. Okay. Picture picture a snake, sea snake. The snake can swim thanks to an inti- intricate partnership between its many pliable muscle cells. In the tech domain, individually energy converters work together like muscle cells to create a larger structure, much like the snake. Most devices use one generator to convert ocean energy into usable, clean, and renewable sources of energy, including electricity. But tech amasses it many tiny converters to form one larger, often flexible energy converter. DeckTech gives researchers and developers an entirely new way of thinking about how to convert marine energy from ocean waves, tides, and currents into more usable form of energy, such as electricity. Borden said. Combined, these tiny energy converters can form the foundation of fabrics, bulkheads, support structures, and more, building a range of DECTEC based energy converting structures. For example, DECTEC based wave energy converts could look like balloons that contract and expand, snakes that undulate, or paddles that twist and bend to harness ocean wave energy. Hmm. These adaptable balloons, snakes, and paddles could come with big benefits to flexible wave energy converters, also known as FlexWaves, can harness and convert waves into usable energy throughout their entire structure. So, no matter where or more how wave energy interacts with a device structure, energy is converter so will be there to transform that wave into power, because FlexWaves do not concentrate ocean wave energy into singular energy converter like a lone rotary generator or hydraulic piston cylinder, or one power transmission system like a drive shaft or a gearbox. They avoid accumulating ocean waves forces that could potentially shut off or damage the missions. Indeed, other wave energy converters often use large steel frames to protect their rigid bodies from oceanic forces, but those frames can be expensive and heavy. Instead, FlexWaves can go with the flow. Hmm. FlexWaves frames could also enable them to harness energy from a far wider range of ocean location and wave energy frequency. One day they could be DECTEC based marine renewable energy farms off the coast of California, Oregon, and or Washington, with these types of wave energy converters potentially powering coastal communities or the utility grid at large. Borden said. Hmm. High costs are one of the last major hurdles, and that's the promising marine energy industry must overcome to start powering those communities. And deck tech flexible archer types could offer an especially cost effective way to harness wave energy because FlexWaves host far more than one energy converter. They could require fewer maintenance trips if only a small group of tiny converters require fixing. All other could continue operating. FlexWaves can also be built with more sustainable, cost effective materials, making them easier to install and control once out in the ocean. Greater control could mean increased energy production, allowing operator to adapt to changing ocean conditions to harness the greatest amount of potential energy. Because the tech domain is still relatively new, Boron and his team are working hard to explore uh, exactly how this technology could create a new generation of marine energy device and other energy generating materials. And Boron recent patent was a big push towards a tech future. The patent gives further credence as to what a tech could become. Of course, that's the main question. Boron said, now we have a patent foundation to further develop and promote tech both with Nedal and with our external collaborators and industry. So yeah, this is the one of the, I mean, new technology stream or technology domain. So yeah, it's interesting. So I guess there is going to be more technology coming in this domain of the tech. Okay, let's see what we get in the future. But for of course, this is the new domain for many of our scientists and researchers all around the world. Yeah. Okay, as we I guess this is the end of this podcast, and as I already previously discussed that we have started a newsletter for those people who are interested in the information that is not easily available on the surface web, and it will be provided only to the our subscribers. And yes, we have started an offer starting from $1 that will be provided from the next year till next year. So it's going to be for few period of time, limited period of time. So if you are interested, subscribe to this newsletter. Otherwise, leave it and enjoy this podcast. Yeah. Till then, keep researching, stay curious, stay healthy.